Concrete is truly the bedrock of our modern world, and at its heart is cement. We have used it to build everything from the tallest skyscrapers that pierce the clouds to the humble garden paths that wind through our backyards. Its strength, reliability, and relative low cost have made it the go-to material for construction projects across the globe for over a century. It's hard to imagine our cities and towns without it. This material has allowed us to shape our environment on an unprecedented scale, providing shelter, infrastructure, and the very foundations of our societies. For so long, we have simply accepted it as the only way to build strong, permanent structures. However, our reliance on cement comes at a tremendous cost to the planet. The process of making cement is incredibly energy-intensive, requiring massive kilns heated to extreme temperatures. This process alone releases vast quantities of carbon dioxide, a greenhouse gas that is a primary driver of climate change. In fact, the cement industry is responsible for around 8% of global CO2 emissions. That's more than the entire aviation industry. As we continue to build and expand our urban landscapes, the environmental footprint of our construction habits grows ever larger, posing a significant threat to the delicate balance of our climate. At the same time, we face another enormous environmental challenge: waste. Specifically, the mountains of paper and cardboard we discard every single day. Think about all the packaging from online deliveries, the newspapers, the food containers. While recycling helps, a significant portion still ends up in landfills. As this paper and cardboard waste decomposes, it releases methane, another potent greenhouse gas that is even more damaging than carbon dioxide in the short term. It feels like a terrible waste of a valuable resource, a material that has already been processed and could surely be given a new, more useful purpose in its next life. So here we are, caught between two significant problems. On one hand, we have a building material that is essential to our way of life, but is actively harming our atmosphere. On the other hand, we have a colossal stream of waste material that is also contributing to environmental degradation. It's a difficult position, and it forces us to ask a very important question. Can we find a way to solve both of these problems at once? Can we reimagine the very materials we use to build our homes, turning our waste into something wonderful and our buildings into a positive force for the environment? The answer to this complex problem might just be found by looking down at the ground beneath our feet and into the recycling bins we put out each week. An innovative new idea combines three simple, readily available ingredients: soil, water, and recycled cardboard. This isn't about creating some highly complex, factory-made composite. Instead, it's about returning to fundamental natural materials and using them in a clever, modern way. The concept harnesses the inherent strength of the earth itself and combines it with a waste product we have in abundance, creating a building material that is both strong and sustainable. The process is brilliantly straightforward and elegant in its simplicity. It begins with large, sturdy cardboard tubes, the kind you might see used for concrete formwork, or large rolls of fabric. These tubes are placed vertically to act as a mold for columns and walls. Inside these tubes, a mixture of soil, a small amount of water, and shredded recycled cardboard is poured in layers. Each layer is then compacted down tightly, a technique known as rammed earth. This process is repeated layer by layer until the entire tube is filled with this dense, solid material, creating a strong structural element from the most basic of ingredients. This method is a beautiful fusion of ancient techniques and modern recycling. Rammed earth construction has been used for thousands of years to create incredibly durable and long-lasting buildings, from sections of the Great Wall of China to historic structures in Europe and the Middle East. The cardboard tube serves as the perfect container, providing the initial shape and support while the rammed earth core cures and hardens. Once its job is done, the cardboard can be left in place as an additional layer of insulation or even be peeled away, revealing the beautifully textured, layered earth wall beneath. The result is a building material with a tiny carbon footprint compared to traditional concrete. There is no need for high-temperature kilns or massive industrial processes. The materials are often available locally, reducing the need for long-distance transportation. The soil can be sourced directly from the building site, and the recycled cardboard comes from our local waste streams. This approach completely changes the environmental impact of construction, transforming it from a carbon-intensive industry into one that works in harmony with the natural environment, using resources that are both renewable and reclaimed. Now, the crucial question for any new building material is, of course, its strength and durability. How does this combination of soil and cardboard compare to the tried and tested might of steel-reinforced concrete? Initial studies and tests have shown incredibly promising results. The densely compacted rammed earth core provides excellent compressive strength, meaning it can bear heavy loads without buckling or crushing. The cardboard tube, far from being just a temporary mold, contributes to the overall structural integrity, adding a degree of tensile strength and flexibility that solid earth alone might lack. It's a symbiotic relationship where each component enhances the other. For projects that require even greater strength, perhaps for taller buildings or those in earthquake-prone regions, there is another exciting innovation that can be incorporated. Instead of just relying on the rammed earth, designers can integrate carbon fiber into the structure. Carbon fiber is a material that is exceptionally strong, yet incredibly lightweight. By wrapping the cardboard tubes in a carbon fiber mesh or embedding carbon fiber rods within the rammed earth core, the structural performance can be dramatically enhanced. This makes the system far more versatile, opening up possibilities for a wider range of architectural designs and applications. However, this added strength comes at a cost. Carbon fiber is currently a much more expensive material to produce than either soil or recycled cardboard. Its manufacturing process is also more energy intensive, which does offset some of the environmental benefits of the core material. Therefore, its use would need to be strategic and carefully considered. It's not a solution for every part of every building, but rather a specialist tool to be used where it is most needed, allowing architects to push the boundaries of what is possible with these sustainable materials, while keeping the overall project affordable and eco-friendly. This is where the real design challenge lies. It's about finding the perfect balance between grand ambition, structural necessity, and environmental responsibility. It's not simply about replacing concrete one for one, it's about rethinking how we design our homes from the ground up. We must consider the unique properties of these materials, their texture, their thermal mass, their connection to the landscape. The most successful projects will be those that celebrate these qualities, creating buildings that are not only strong and efficient, but also deeply beautiful and connected to their origins. This is the essence of truly grand design. Despite the enormous promise of this new approach, there are still significant hurdles to overcome before we see soil and cardboard homes popping up in every neighborhood. The most important next step is rigorous and comprehensive testing. We need to fully understand the long-term durability of these materials. How do they perform over decades of exposure to rain, wind, and changing temperatures? How well do they resist moisture, pests, and fire? These questions must be answered with scientific certainty before this material can be widely adopted for building the places where people live and work. Beyond the technical challenges, there is the formidable task of navigating the world of building regulations and codes. These rules are in place for a very good reason, to ensure our buildings are safe. However, they are almost exclusively written around traditional materials like concrete, steel, and timber. Introducing a completely new material system requires a mountain of paperwork, testing data, and certifications to convince local authorities and building inspectors of its safety and reliability. This process can be slow and expensive, often acting as a major barrier for innovators hoping to introduce greener alternatives to the market. However, the potential rewards are so great that we must persevere. Imagine a future where our buildings are no longer a major source of carbon emissions, but are instead constructed from local, natural, and recycled materials. A future where our homes have a direct connection to the earth they stand on, with beautiful textured walls that breathe and help regulate the indoor climate naturally. This isn't a fantasy. It is a tangible possibility that is within our grasp. It represents a fundamental shift in our relationship with the built environment, moving from an industrial model to a more organic and sustainable one. This is more than just a new building technique. It is a new philosophy of construction. It's about being smarter, more resourceful, and more attuned to the needs of our planet. By combining ancient wisdom with modern ingenuity, we can turn our waste streams into valuable resources and create homes that are not only shelters, but are also part of the solution to our climate crisis. The road ahead requires patience, investment, and a willingness to challenge old habits, but the prospect of building a cleaner, greener, and more beautiful world makes it a journey that is well worth taking.